Okay, so we're practicing balancing equations. We'll do half of these together and then you try the other half on your own, all right? So first we're going to write down what the elements are. So I have zinc, hydrogen, and chlorine. All right, I have zinc and hydrochloric acid. So now I count how many I've got on each side. So there's one here, one of each of all of these. And then over here I've got one zinc, two chlorines, and two hydrogens. All right, so the zinc is all by itself, so I'll go ahead and balance out the hydrogens and chlorines. So I have two, so I need to double it, right? So that's easy, right? I'm going to double this side and I gotta double this side. Well, in order to do that, I'll just change my coefficient. All right, I can put a number in front. I cannot change the subscripts because that would change what it is. So I'm just putting a number in front. So now I have 2 moles of hydrochloric acid, and that meant that I had 2 hydrogens and 2 chlorines over here. All right, and I still have 1 and 1, so that actually is good. I have 1 zinc, 2 hydrochloric acids, 1 zinc chloride, and 1 hydrogen. And so your answer, if you're doing like a multiple choice, it would be 1, 2. You just put the coefficients, 1, 1. All right, and now that is balanced. Perfect. Okay, number 2. So we'll just write down our elements. We've got silicon, oxygen, hydrogen, and fluorine. All right, so now we'll count what's the elements on each side. So 1 silicon, 2 oxygens, 1 and 1. All right, so the first 2 steps are easy. You're just writing down what you've got. You don't have to think about anything. I've got 1 oxygen, right? Because if there's nothing there, that means there's 1 oxygen. This 2 goes with the hydrogen. So I have 2 hydrogens, and then I have 4 fluorines. All right, and now everything, I don't have anything single out there all by itself, so I'll just start with the fluorines, right? So I have 4 over here, so I need 4 over here. So I'm going to times that by 4. So to do that, I would have to put a 4 in front, right? I changed the coefficient to a 4. It was a 1, now it's a 4. And what that means is I have 4 fluorines, which is fantastic. And I also have 4 hydrogens, right? So, because remember that means I have 4 moles of hydrogen fluoride. So that's 4 moles, right? The coefficient means you have 4 of these things. And so when I'm counting up the elements, 1, 2, 3, 4 hydrogens, so I'll cross that out, make that a 4, and I have 4 fluorines. So there we go. So now that means over here I need to have 4 hydrogens in my products. So if I want to do that, I've got 2 as my subscript, so I'll put a 2 in front, right? Because what that means is I have 2 waters, right? So 2 moles of water, H2O, H2O. So altogether, 2 plus 2, that would be 4 hydrogens. And then here, they actually get multiplied, 2 times 2. All right, so I have 4 hydrogens, and I also have 2 oxygens. 2 times 1 is 2. So I have 2 oxygens. I'll change that to a 2. And my silicon was already balanced 1 and 1. So 1 silicon and 1 silicon. All right. So that answer there would be 1. If I'm just looking at the coefficients, 1, 4, 1, 2. Okay, and then I forgot on the last one, I didn't do the check. You always do the check because it's really easy to make a mistake. So I've got 1 silicon, check. 2 hydrogen or 2 oxygens, right? 2 times 1, so that would be 2 oxygens. And then over here I have 2 oxygens, 2 times 1, so check on the oxygen. And then I've got 4 hydrogens, and I've got 2 times 2 is 4 hydrogens. And then fluorines, I've got 4 fluorines and 4 fluorines, so check on that. That is a very, very important step because you can see how changing one thing changes other things, and you kind of get, it's easy to make a mistake. So that is that, and this would be my final answer if I'm just looking at the coefficients. All right, so now I've got up here, I've got selenium, chlorine, and oxygen. All right, then I'm going to count so that there's a 1, right? 1 selenium. The 6 is with the chlorine. And then I have 2 oxygens. And then over here I've got 1 selenium, 2 oxygens, and 2 chlorines. All right, so like we did when we were balancing equations, we want to have, we use the least common multiple. So I'm going to kind of do that here with my chlorines, right? I've got 2 and 6. So if I count by 2s, 2, 4, 6. So I can make this be 6, right? 2 times 3 is 6. So that means I'm going to put a 3 in front. Okay, I can make that, I can change the coefficient. 3 times 2 is 6. So now I have 6 chlorines. And over here I had 6. And then now everything else is balanced. So I'm going to have one of these, one of these, one of these, and 3 of these. So that was nice. All I had to do was change one thing. All right, let me check and make sure I did not make a careless mistake. 1 selenium, check. 6 chlorines, and 3 times 2 is 6, so that's 6 chlorines. And then 1 times 2, that's 2 oxygens and 2 oxygens. So that is definitely correct. All right, number 4. So I've got nitrogen, hydrogen, and, oh, that's all I've got over here. I was going to write ammonium. I don't need to do that. Okay, so I just have nitrogen and hydrogen. Let's see. I've got 2, right? First step, element. Second step, count. 2, 2. 1, right? Because the 3 is only with the hydrogen, and 3. So now here again, I'm going to use that least common multiple with 2's and 3's. So 2, 4, 6, 3, 6, 9. So they both have a multiple of 6. So to make this be a 6, I'm going to times it by 3. Oops, I didn't want to put a 3 there though. I want to put a, I'm going to put how many I want. I want to have 6, right? And then to get the 6, I multiply 2 times 3 is 6, all right? And then over here, I want to have 6 as well. And to get 6 hydrogens, 3 times 2 is 6. So now I have 6 hydrogen on the left and 6 on the right. And then what happened with my nitrogens? Well, when I put this 2 in front as a coefficient, that also doubled my nitrogens. So now I have 2 nitrogens. And then I'll do a quick check. So I have 2 nitrogens and 2 nitrogens, so check. And I've got 6 hydrogen and 6, 2 times 3 is 6 hydrogen. So my answer there would be 1, 3, 2 for the coefficients of that balanced equation. Okay, so let's look at number 5. We've got aluminum and oxygen. So now I'm going to count. I've got 1 aluminum, 2 oxygens. Over here in my products, I've got 2 aluminums and 3 oxygens. All right, so here we go. Least common multiple is 6. So I want to have 6. So 2 times 3 is 6, right? 2 times 3 is 6. And then over here, I want to have 6. So it's going to be 3 times 2 is 6. So 2 times 3 is my 6. Let's see. So over here, 2 times 2 is 4. Now I have 4. So when I put the 2 in front, that doubled my oxygens, right? But it also doubled my aluminums. So that's easy though to fix, because now I have 4 on the right. I want 4 on the left. 1 times 4, right, is 4. So 4 is my new coefficient here. So my coefficients are going to be 4, 3, and 2 to get my balanced equation. And then now I'm going to check, make sure it's correct. 4 aluminums, 2 times 2 is 4. 4 aluminums. 3 times 2 is 6, and 3 times 2 is 6. All right, so I know that that is correct. Now I'll go to 6. I've got carbon, oxygen, and hydrogen. So now I'll count 1, 1, and 2. And over here I've got 8 carbons, 18 hydrogens. Oh, no, and there's 2 more there, right? So that's actually 20. So I have 20 hydrogens. And that's kind of a pain when they're split up like that, right? So let's see. I've got, I'm going to have to think a little bit more. And then I've got 1 oxygen. All right, so, but they're both even on both sides, right? Notice over here with my hydrogens, my subscript is 2, so 2 times anything is always going to be an even number. I got to make sure my coefficient here is, and these are always going to be even too, because I've got 18 and 2. So these are going to always be even, so I don't really have to think about that. So, and this hydrogen's all by itself, so I really don't need to worry about that. That's easy to fix too. If I change this coefficient, it doesn't change anything else. So let's start with our carbons. I need to have 8, right? So I'll make that be 8. And if I put an 8 carbon here, that gives me 8 oxygen too, right? It kind of gets distributed. So I have 8 carbons. I also have 8 oxygens. So over here, this subscript is 1, so 1 times 8 is 8. All right. So that changed my hydrogens, because now I have these 18, but now I also have 8 times 2, I have 16 more. All right, so 18 plus 16, right, if I add those together, 18 and 16 is 34. So now over here I have 34 hydrogens. So what I'm going to do is I want to have 34 over here. 34 divided by 2, all right, because I'm trying to figure out what do I multiply here to what times 2 equals 34. So 34 divided by 2 is 17. 17 times 2 is 34, right? Because I want to have 34 on both sides. So now I'll do my check. Let's make sure they're equal. It's balanced. 8 carbons and 8 carbons, right? So this will be a 1. So check. And then I've got 8 oxygens and I've got 8 oxygens. So check on the oxygens. I didn't change my numbers, but I've got 8 oxygens and 8 oxygens. And then now 17 times 2 is 34, and 18 plus 16 is 34. So 34 and 34, so that is correct. So my coefficients would be 8, 17, 1, and 8. All right, you can only change the coefficients. You cannot change the subscripts. And now it's balanced. All right, so number 7, make a list of the elements: silicon, chlorine, hydrogen, and oxygen. Count: 1, 1, 4, I'll just go down the list. I'll do the left and right. I think that's better. 2 hydrogens and then 1 oxygen. And over here, 1 silicon, 2 oxygens, 1 hydrogen, and 1 chlorine. All right, so that's balanced. I need to have 4 chlorines, right? So if I make this 4 chlorines, I put a 4 over here. So that gives me 4 chlorines, but that means I also have 4 hydrogens, right? And if I have 4 hydrogens, I want to have 4 hydrogens over here. So I want that to be a 4. Well, 2 times 2 is 4. So now I have 2 hydrogens, right? But then I also have 2 oxygens. And it's so nice when that happens, because now if I go back to check, right, I've got 1 silicon, check, right, 1 and 1. How many chlorines? 4 and 4, check. 4 hydrogens, and 4 hydrogens, check. And then now oxygens, I've got 2 oxygens and 2 oxygens, so check. So my coefficients are 1, 2, 1, 4. And it's balanced. Because remember, that is the conservation of mass. Matter cannot be created or destroyed. So if you start out with this much mass, you've got to end up with this much mass. Nothing just disappears. So I've got gold, sulfur, and hydrogen. Oops, forgot to lift off there. So now I'm going to count 2, 3, 2. And over here I have 1, 2 hydrogens, and 1 sulfur. All right, so I've got to triple my sulfurs over here. So to do that, I will have to put a 3 in the front, So now I have 3 sulfurs over here, right? But that tripled my hydrogens. So 3 times 2 is 6. So I have 6 hydrogens. So over here, I've got to have 6 hydrogens. So 2 times 3 is 6. So now I have 6 hydrogens on both sides. 3 sulfurs on both sides. And then golds, I have 2 over here. I want to have 2 over here. So I'll just put a 2 in front because there was 1. Subscript is 1. All right, so that would be my final balanced equation. All right, let's do a quick check. So I've got 2 golds, right? 2 golds and 2 golds, so check. 3 sulfurs, 3 sulfurs, check. 6 hydrogens and 6 hydrogens, check. All right, so the coefficients are 1, 3, 2, 3 for my balanced equation. All right, we will do one more and then you can do the rest on your own. I've got iron, hydrogen. Oh, here I have a polyatomic ion. You want to keep those all together, so I'm glad we did this one. All right. We might actually have to do another, we'll do the next one too. All right, so, and then we'll count. So I have 1, oh, I forgot my E to make that iron. All right. So I have 1 iron over here, 2 hydrogens, and 1, this is 1 sulfate. All this together, right? Would just be, that's just 1 sulfate. All right, so, and notice, remember the H is in front, so this is actually sulfuric acid. All right, so over here, here's my subscript. So I have 2 irons. I have this subscript 3 means I have 3 sulfates. And this subscript here means I have 2 hydrogens. Okay, so I want to have 3 sulfates on both sides. So let me make this into a 3. So that means my coefficient here would be a 3. 3 times 1, that means I have 3 sulfates. All right, because it would be H2 SO4 3 times. That means I have 3 moles of that. It's hard to write fast. But anyway, you see there's 1, 2, 3 sulfates. Okay. Now what that meant is I have that tripled my hydrogens here. So now I have 6 hydrogens here. So to get 6 hydrogens over here, 2 times 3 is 6. And then now my irons, I have 2 over here, and I want to have 2 over here. So luckily, this iron is all by itself, and that's not going to, putting that coefficient is not going to change anything else. So it looks like it's balanced. Let's just check to be sure. 2 irons, 2 irons. Check. 6 hydrogens and 6 hydrogens, check. 3 sulfates and 3 sulfates, check. Right, because that would be 1 times 3 sulfates. Okay, so my coefficients are 2, 3, 1, and 3. And what we learned here too is if you have a polyatomic ion, you count that as, you keep that all together as, you treat it like an element. And again, that's why we studied those, is so we can spot them. All right, so here we'll do 10 and then I'll let you go off on your own. So this is one where you've got a polyatomic ion. Actually, you have two of them. You have the OH, you have the hydroxide, and you have the phosphate. See, aren't you glad you worked so hard on these? We have potassium, and then we had hydrogen. Now, when you have water over here like this, when you have an OH and an H as your elements, let's write water as H-OH. Right, H2O. But this makes counting the H's and the OH's easier. All right, so over here I have one potassium, I have one hydroxide, I have 3 hydrogens, and 1 phosphate. And here I've got 3 potassiums, 1 phosphate, and here I've just got 1 water, so that's 1 hydrogen and 1 hydroxide. All right, so what I need to triple here is my potassiums, right? So I need 3 on the left, so I'll put a 3 for my coefficients. Now I have 3 potassiums. That means I also have 3 hydroxides. So that tripled that. All right. Now, if I triple this hydroxide, right, I want to triple this. Well, maybe I'll put the 3 here. All right. So this means I have 3 hydroxides here, right? But then I also now have 3 hydrogens. So I have 3 hydroxides, and I also have 3 hydrogens because it tripled everything. Right? 3 hydrogens, 3 hydroxides. Now everything looks balanced, actually. Thank goodness. All right, so now let's do the check. 3 potassium, 3 potassium. So that's good. 3 hydroxide and 3 hydroxide. And then now I've got 3 hydrogen and 3 hydrogen. And then I have 1 phosphate, right? 1 phosphate and 1 phosphate. So that checks out. Okay, so that was not so bad. So that's 3. You just have to kind of do it one step at a time. And if you have to go back and, change it, then that's what you do. It's kind of like when you were learning how to factor. All right, so very good. That's it. Try the rest on your own, and we'll make a key for you to check. All right, but see how you do on your own. Good luck.